Let's start with the partner event. For those who are attending the event for the first time, this is like a monthly event when we are trying to share some interesting ideas. The ideas can be sales related, they could be technical like knowledge that is important in the industry. And in this case, we decided to focus on one specific topic of driver behavior, which will be more like an explanatory or like educational material about the driver behavior solution that we have built in the Mapon platform. And today we are several hosts. I'm Ingus, and Andris is the second CEO of Mapon. And we also have today Raitis, who is the project manager for the driver behavior solution, and he is I would say the smartest person in the Mapon regarding driver behavior solutions, and he has been the one who has been driving with his own vehicle to understand how his driver behavior actually translates into data into Mapon platform. So yeah, I think that I can give the word to Raitis, and he will move on with the presentation. The presentation process is the same as usual. Like having a presentation, you can usually ask questions in the chat in the meantime, and we will try to cover those questions later on in the Q&A session. And if you have some questions at the end, then also feel free to shoot them, and we'll do our best to answer that. So yeah, thank you. That's it for the introduction, and Raitis, you can easily start the event with your presentation.
Okay, thank you, Ingus, for introduction. So yes, as Ingus told, my name is Raitis. If someone doesn't know me yet, and I am the project manager in Mapon, and I am working with driving behavior. And today's agenda is I will tell you more about driving behavior, remind you the purpose of it and why we made it. And after that, I will explain in more detail about each parameter, how it's calculated, and share information about some driving tips. And in the end, I will share some experience from our existing clients, and we will have a questions and answer discussions. Okay, let's go to the first slide. So in this slide, you can see the cost of the transport, and the cost of the transport can be variable, depends on the country or region where the vehicle operates. But if you look at the number, then the fuel cost takes more than 1/3 of all the costs. The second biggest part is wages. Wages also takes a huge part of all the transport costs, and then comes to the purchase payments, insurance, benefits, repair costs, tire costs, and toll road and licenses costs. The biggest question for the company manager is always how to decrease the costs and how to increase the profitability. And one of the biggest costs here is fuel, and driving behavior. Driving behavior is one of the solutions which helps to understand and analyze these costs for the company. Let's go next, and there I have put a table where you can see how different factors can increase the fuel consumption. So if we assume that the nominal truck fuel consumption would be like 25 liters per 100 kilometer, then aggressive drivers could increase it by 25%. This can lead to fuel consumption up to 30 liters per 100 kilometers. If we add up speed, for example, from 80 to 90, then the fuel consumption can increase by 3 extra liters per 100 kilometers. Route sections like road type, a grade, can also increase the fuel consumption by 6%. Tires are also very important in fuel consumption. Also, tires with high rolling resistance can also lead in fuel increase. Totally, if we take all the factors here, then we can see that fuel consumption can increase by almost 56% or 14 liters per 100 kilometers. So if we calculate it in the cost, it would be like something like 17 euros per 100 kilometers. So if we take all these factors. And then comes the driving behavior. And driving behavior is, we have created to help to understand which are the risky factors for drivers, which are the factors which can increase the fuel consumption, and driving behavior can reduce the fuel consumption in the way to understand which are the positions which need to be increased, reduce the maintenance cost for the truck, because together with fuel consumption, there's also the wear of the parts for the vehicles and so on. Increase the safety in the traffic, reduce insurance costs, which can increase if the driver makes an accident, and of course reduce the environmental impact. Categories by which driver habits are analyzed. We have created multiple parameters in driving behavior. In driving behavior, we measure like 8 parameters to give a total score for the drivers. Each parameter is giving a score which is then added to the total score. The driving behavior score could be calculated for the vehicle or driver. For example, we can see how does vehicle performs with multiple drivers, or how does the driver performs with multiple vehicles. And at the end of the month, a client can generate a driving behavior report and share it with the other drivers, or share it with the manager, or so on. In case if driver or managers want to see the analyze more detail, it is possible to see even events also on the map. The map allows to filter out like risky events and see the exact time and location where it has happened. And to follow up driving score, drivers can also like download and see their total score in driver mobile application. If we go next, then here I will start to speak about each driving behavior parameter. And the first parameter is echo speed. And echo speed is a parameter where we calculate if the vehicle speed exceeds the maximum speed limit which is set by the company. The biggest saving is for trucks here, which can lead up to 14%. For example, decreasing the speed from 90 to 80 kilometers, truck drivers can save extra 3 liters per 100 kilometers. And here the speed is measured from GPS data and displayed as total driving time, percentage of total driving time. So yeah, here we are calculating the maximum speed for the vehicle and displayed it as a percentage of total driving time. Next parameter which we are measuring is excessive idling. Excessive idling is a time when the vehicle is idling more than a specific time, and is displayed also as a percentage of the total driving time. Idling data are mostly taken from the ignition. For Mapon devices, idling can be also set from RPM, which give the higher accuracy. And from the RPM range, we can tell if the vehicle is doing real idling instead of ignition. For example, RPM gives us if the engine is turned on or off, because ignition can only tell if ignition is on, but not tell if the engine is started. You can turn on the ignition, but not start the engine. And recently, also to excessive idling, we have added a PTO or power takeoff switch. This means that if the vehicle is standing with the engine on, but PTO is also on, then it will not be counted as excessive idling. PTO, if someone doesn't know, for example, PTO is like an extra, I would say, like extra engine in vehicle. For example, there's a trucks which deliver the fuel to the fuel stations. When they go to the fuel station and they want to pump out all the fuel to the fuel tank in fuel station, they turn on this PTO. That means that vehicle is standing and running the engine, and it counts as excessive idling. But if we have this PTO data, we can tell that it's not excessive idling, but vehicle is working there. They are pumping out the fuel, and it will not be an excessive idling. Yeah, and excessive idling is very important because the fuel consumed in idling is up to 2 liters per 1 hour. For example, the engine should be switched off when stopping for more than 2 minutes. It's just not because it's against for the rules in other countries, but also in 10 minutes of idling, you consume 30 milliliters of fuel. So it's also a huge consumption. Okay, let's move to the next. Cruise control usage. So we also measure cruise control in driving behavior, and cruise control is a great way to decrease the fuel consumption since it smoothens the drive and is more protective of the engine. And cruise control can give saving up to 7% of fuel on highways. Pure cruise control usage is available mostly for trucks with the CAN connection, and it could be get from the Teltonica and from Mapon devices. Cruise control is also displayed as the percentage of total driving time. So if you drive 100 minutes and cruise control usage is 10 minutes, then cruise control will be 10%. Also, why we measure cruise control? Because cruise control, when the driver drives with the cruise control, it doesn't make the movements in the pedal, because cruise control keeps the speed steady. If the speed is not steady, it's like you are driving without cruise control. Your pedal is moving a little bit, but it's moving, and that increases the fuel consumption, and it's very important. And for modern trucks, there is option to have adaptive cruise control. Mostly for new trucks which are coming out, they have this adaptive cruise control, which knows when the vehicle will go uphill, when the vehicle will go downhill, and this adaptive cruise control knows when to accelerate and when to release the brake pedals. Okay, let's go next. Costing. So I think this is one of the most important parameters in the way to decrease the fuel consumption. Parameter measures how efficient is the driver, is he using the inertia of the vehicle, and how well the driver can predict the traffic. Costing is detected when the costing is detected by checking multiple vehicle parameters in the one time. So to detect the costing, vehicle should move 5 seconds with cruise control off, with accelerator pedal off, brake pedal off, and speed should be over 10 kilometers per hour. Then we tell that that the driver is coasting and he is using the vehicle in Mapon. For example, weight of fully loaded truck is around 40 tons. So, and the power of inertia is so strong that car can drive along this distance with zero consumption. So imagine a 40-ton trailer moving on the road. This trailer inertia is so big that he can move without acceleration long distance and without losing speed. Yes, and yeah, and just a moment. Yeah. Okay, let's move next. One of the last parameters which we are also measuring is harsh braking, acceleration, and cornering. These parameters will not only find the uneconomical drivers, but will also help to find out risky drivers, which can lead to accidents and higher insurance costs. A sharp increase and decrease in speed will be detected as harsh braking or acceleration. Acceleration and braking are calculated from CAN and secondary from GPS data. So if the car has possibility, if the device has possibility to read CAN data, CAN speed, then we use CAN speed to detect acceleration. If not, then we use GPS data. CAN, because CAN is more accurate. Acceleration and braking are calculated from CAN. Are calculated in G-force. If we calculate the G-force to kilometers per hour, then it's around 10.9 kilometers per hour in 1 second. That you will increase and will be detected as acceleration force. So if, for example, if the braking force is 0.39 G-force, then if you brake faster than 13.9 kilometers per hour in 1 second, then it will be detected as harsh braking. And for cornering, we are also using the G-force, and cornering is detected only from GPS data. Cornering we detect from coordinates. For example, we have like 3 coordinates, 3 points, and if we draw a line across all these 3 points, we can get the angle, and by this angle and by the speed, we can calculate the g-force, which and we can tell if the vehicle was going very fast in the turns or not. Also, for example, good example for the acceleration and braking is that if we stop the car or truck unnecessary and want to accelerate this 40-ton truck from 0 to 80, it will cost us almost 0.5 liters to accelerate this truck. So it means that half of the liter we spend when we want to accelerate the truck from 0 to 80 kilometers per hour. The last parameter which we measure is driving green RPM. The economical, like operational range for diesel engines is around 50 to 60% of the nominal engine speed, and which is approximately 70 to 90% of the acceleration pedal. So basically, if we accelerate the car and we press pedal till the end, till 100%, then it will be definitely an uneconomical drive. So the green RPM, this is something which is also seen in truck speedometer. If we get in the truck, we can see that in the truck there is like in the RPM there's a green this field, and driver should keep the RPM in this green field, which means that driver will do the most economical acceleration. And this is also one of the most important parameters for having the good fuel consumption. And RPM we can get from CAN, and currently it's supported for Teltonic and Mapon devices. Okay, let's go to the calculation table. In each like driving here parameter has a grade from A to G, and the grades are assumptions that are based on the tests with the clients and research. There is like no single like system in the globe to look how many cruise control usage is considered as a good and how much like braking force or braking times are considered as bad. That's why like products like driving behavior could not be compared with other company products. For example, if I would say like that I brake 5 times last week, is it good or bad? Should I be C or A? So it's an assumptions based on research and based on another research. That's why companies clients who have like 2 type of trucks, Mercedes and Volvo, they have 2 different like driving behavior management systems. It's not good to like evaluate drivers in like one table. These are like 2 separate products. Of course, the trends will be similar, but it's not like the data will be the same as another system. What I wanted to show in this table that each parameter is this grade from A to G, and most of the parameters we are calculated the percentage of total driving time. So if the truck is driving like 100 minutes, and coasting is 5%, is 5 minutes, then coasting parameter will be like 5% of total driving time. The only three parameters which we are not like calculated based on the driving time is acceleration, braking, and cornering, because these are the events which don't have like a time interval. Basically, you have a harsh braking, and that's all. That's an event. So these events we are like calculated based on incident, based on number. So we assume as we have an assumption that if in 24 hours of driving you have acceleration, for example, 7 times, you will get B. But if you drive not 24 hours but only 12 hours, then with seven brakings you will have probably just C, not B. Okay, let's move next. I wanted also to share in this meetup also solution which we have recently added also for driving behavior. It's the different weights for each parameter. So this means that you can set for each parameter your weight. For example, some companies think that echo speed is more important than braking. So in the system you can find the settings where you can set these weights. So then the bigger the weight, the bigger importance of the parameter, and this gives clients very good like customization for the driving behavior. Okay, let's move next to the case studies. The first case study what I wanted to share is Grace. Grace was is one of our like longest, oldest customer, and driving behavior was built also together with Grace. Grace they are pretty huge. They have a lot of drivers, and fuel economy is very important for them because it takes the biggest part of all of the costs. And for drivers, they have a driving school. They even have this driving school. If driver, for example, um, fuel consumption has more than 33 liters per 100 kilometers, they send this driver to the driving school, and then driver learns how to drive. And I was also sitting in the car with this driver and see how they were teaching the drivers. And the interesting part was that when the driver gets in the car and he show how he drive, they make a test drive like 40 minutes, and driver shows how he can drive, how much fuel he can save, and so on. And when they finish the first test drive, then the teacher shows this driver how to drive, and then they make the second time this distance. And interesting was that when driver drives this first drive, his fuel consumption was 31 liter per 100 kilometers. But second time when the teacher tell these tips, what to do, how to do, they decrease fuel consumption from 31 to 25, 24, something like that. And yeah, the biggest gain was from usage of inertia. For example, this 40-ton truck is so heavy that the inertia of the truck is so huge that the truck can move like even 2-3 minutes without decreasing the speed. Yeah, and that was the biggest gain actually. So they predict the turns, they predict that there will be a traffic red traffic light, they predict the traffic. So this gives this huge savings. Yeah, that's about the craze. The next case I wanted to show you one client. I will show you the video and let's watch the video. So this is one of our clients which has an accident. Accident happened because the driver goes too fast in this road. For example, this is like a circle. He drives in the circle too fast and get this accident. And I also find out the historical data for this driver, and yeah, you can see that it's hash cornering here, and in video you can also see that driver was driving too fast in this road. And this client, he's also like using driving behavior to improve the driving safety, to decrease the fuel consumption, and he's also like very happy with this solution. So it really helps for them. Okay, let's move to the next one. So yeah, I will give yeah to Ingus.
I will take on from here just to share the third case study, and the third case study is I would say a bit more optimistic than the, the previous one with the car crash, and the third case that is interesting for us is Berchi. Berchi is a European company which is transporting chemicals with trucks and also with trains and ships. And currently they have something like more like 1,100 trucks, which means that that's a lot of operations they have. And basically, due to the fact that they're transporting chemicals, it's very important for them to manage safety, and they have internal guidelines on all of the stuff that drivers have to do in terms of safety checklists and things like that, in order to avoid any of the crashes. And if you saw the previous video with the truck crashing on the roundabout, then that's something that Berchi is also trying to avoid. And due to this, they have implemented this bonus program for the drivers. And now that they have implemented it for quite some time already, they are actually sharing the information about the results of their driver excellence awards publicly. And just a couple of days ago, we saw on LinkedIn that they are using our brand to promote their own driving style, like importance and things like that. So basically, whenever you're operating with customers which are interested in road safety and avoiding car crashes, this is something that is important to them. And the interesting part is that not only giving scores to the drivers, they're also providing like prize money for the best drivers. And we see this use case over and over again, that transport companies understanding that they can save lots of fuel by driving economically, they are ready to give some of the cash back to the drivers. And then we can see like companies doing gamification, like in this case, where they obviously have some dashboard where you can see the best drivers and things like that. And yeah, if the driver understands that he is being tracked for his driver behavior, that's one thing. But if he is provided a motivation for keeping the driver scores good, then that's a totally different story, just because he's feeling the monetary reward for saving fuel. And I think that the craze also has some motivation program that if you are driving with the vehicle below some certain amount of fuel consumption, then you are also getting some extra money. But the only difference is that they are not really focusing that much on paying money for drive behavior, but not more for the fuel savings. But yeah, I think that this last case is a good example on how you can actually get additional marketing exposure for the services that you provide. And this is also like giving you leads to continue the sales process. We can end for today. As usual, we are announcing also the next event. The next event is planned for June 17th, which is around 1 month from today. And we're still waiting for your suggestions on the topics. So if you have some topic that you are willing to have discussed, or maybe you have some interesting cases that you would like to share with the partner network or something, then feel free to reach out. And most likely, if we don't have any like very interesting events or ideas from the partners, we will announce the topic of the next event during the next week. And yeah, I think that's it for today. And see you in on 17th of June. And once again, thank you, Raitis, for the presentation. And yeah, see you in a month.
Okay, thank you everyone also for the listening. Good.
Thank you, Raitis and Ingus and everybody.
Thank you.
Thank you.
Bye.
Okay, bye.
Bye-bye.
Bye.